All right, we're live. Hello, hi everybody. Good afternoon. How are you doing today? I'm Anushree, your teacher, your mentor, and I welcome you to this brand new one-shot session targeting Neet 2022, where we are covering 11th grade chapters. Yeah, one shot for 11th grade. So, how are you guys doing? Tell me in the chat window, are you able to hear me properly? Are you able to see me properly? Is everything okay today? Yeah? Come on. Okay, I can see Atul. Hello. Hi Atul. Hi Soumya. Helen Heaven. All right. Hello, good afternoon. What is your name? What you guys can do is you can write your names as well, yeah? So, Varsha. Hi, good afternoon, Varsha. Shaikh. Hello. Hi Soumya. Aismananda. Good afternoon Karthik. Hi Atul. Good afternoon. Hi Ashwini. Hi Andini. Anya. Hello Anya. Hi Aakash. Hello Kalpesh. Good afternoon live. Alright, what is your name? Okay, I can see a lot of people are here. Hi Aditi, hi Vansh, hello Akash, hi Chetan. Lobongo official, hello, good afternoon. Hello Devendra. All right. Ravi, hello Ravi, hi Parth, hi Riya, good afternoon. I hope you guys can see me properly. I hope you guys can hear me properly. If you can, give me a thumbs up in the chat window. Yeah? And well, here we are, right? So we've been doing one shot for 12th grade and we've been covering chapters targeting Neet 2022. But a lot of you asked us that we need 11th chapter as well. And I understand, definitely. So here we are with 11th grade one shot so that you can enhance your preparations. And now we have these parallel one shot series going, right? So 2 sessions in a week for 12th grade one shot sessions and 2 sessions in a week for 11th grade one shot sessions, right? As you can see, preparation for Neet is a marathon. You know that, right? It's a marathon. Now is the last leg of the marathon. As I say, now is the time to sprint. Now you can't stay back. Now you can't fall back. You have to sprint, right? And that is what we are here for. You work hard and we work hard and together we will crack Neet. All right? Okay. All right. I can see a lot of thumbs ups here. I can say, well, there is no connectivity issue, no network issue. And without further ado, let's start. Let's get started. Before we do that, I want to say that, well, when we talk about physics in 11th standard, right? Mechanics plays a really big role and understanding mechanics. Now, all the chapters of mechanics are pretty much linked, right? So once you understand kinematics properly, you will be able to understand dynamics properly, and then we'll go to, well, rotational dynamics and so on and so forth, right? So here I would say, do not miss these sessions. Okay, and if you end up missing these sessions here or there, then please go back and watch these sessions. Right? Now, I understand that, well, especially for Neet students, physics, since it involves a good amount of mathematics, it might look difficult. It might feel difficult for you, right? But that is not the case, right? When you understand physics from the basics, physics can be a really fun and easy and engaging subject and a very scoring, especially for Neet, it can be rank determinator. Right? It can make a huge amount of difference. So let's get started. And before you come to these sessions, just make sure you go through NCERT textbook properly, revise NCERT textbook properly, and then come to this session. After this session, you will find mind maps, you will get the notes also. So don't worry about copying a lot of notes, writing a lot of notes in between the session. All right? And learn properly, understand everything. If you do not understand anything, do write it in the chat window. Ask your questions in the chat window and I will keep answering them. Keep yourself engaged in the chat window, right? Let's keep having that back and forth. All right. Now, yahan pe I can see a lot of Other comments? Okay. Hello Varsha. Hi Bikash. Thanks Priya for confirming. कोई issue नहीं है. Atul is asking, is this batch an English batch? Atul, language will not be a problem. मैं आपको हिंदी में भी समझाऊंगी, English में भी समझाऊंगी, so that you understand everything really well. Okay? All right. Now, Ishika is asking vectors. Okay, yeah. Ishika, the thing is, vectors का application होता है बहुत ज़्यादा. So हम motion in 2D start करने के पहले vectors को basic तरीके से देख भी लेंगे. All right, and we'll solve questions. Questions solve करते करते आपको vectors की understanding होती चली जाएगी. All right. Okay. Now, yes, it is a English session. Now, without further ado, let's start. So, in today's session, we are doing, of course, we're starting with kinematics. In kinematics, we're starting with motion in one dimension. All right. And these are the subtopics that we'll be covering broadly, which is introduction to motion, uniformly accelerated 1D motion, graphs in kinematics. Right. Now, of course, you understand that in physics, we have to understand everything from the basics. Basic concepts, agar aapko samajh mein aa jate hain, if you understand the basic concepts really well, then everything relies on the applications. You should learn how to apply these in the questions, how to solve questions really quickly, and that is what we are going to do in these sessions as well, right? Focus on concepts as well as applications of these concepts. So, let's go, let's go. Ishika says, ma'am, your sound is too low. Ishika, can you look from your end also? Sound के बारे में, can everybody hear me properly? बाकी लोगों को भी sound low लग रहा है क्या? Can you guys tell me? All right. In the meantime, Ishika, try increasing the sound from your device itself. Yeah. From our end, well, my people who are helping us with technician, yeah, they're saying it's good. All right, Bikash, thanks for confirming. Sound is perfect. Let's move on. Let's get started with the session. All right, thanks Soumya, thanks Pranali for confirming. Let's go. First, introduction to motion, right? Now, introduction to motion, matlab sabse pehle let's go through the important terms that are associated with study of motion, right? What do we do in kinematics? Mechanics as a whole is study of motion, right? In kinematics, what we do is we study how of the motion. How is the motion happening? Kaise ho raha hai motion? And in order to understand how of the motion, we have certain terms that we study about, that we analyze, right? So, first of those is dimension. Now, what is a dimension? In any mathematical space, dimension is the minimum number of independent information that is required to specify the point in that space, right? Specify its position. So here, I can say that, well, in the topic also you see, right? Motion in one dimension. That's what we talk about, 2 dimension. What does that mean anyway? See, motion can be in 1 dimension, it can be in 2 dimensions, it can be in 3 dimensions. It means that if the motion is happening along the straight line, right? It's linear. That means in order to understand the position of the point at any given instant, what do we need? We just need to figure out its x coordinate, right? Its position along x-axis, that's it. Only one information is needed. That's why it is motion in 1 dimension, linear motion. If I talk about motion in a plane, right, it becomes a 2-dimensional motion because, as you can see, right, this ball that is moving, come on, I'm going to start this, see how this ball moves. As this ball moves, when it is over here or here or here, we understand that in order to specify its position, we need 2 independent values, right? We need to understand where it is along x-axis and where it is along y-axis. X-axis ke along kahan par hai or y-axis ke along kahan par hai? That's what we need. So 2 information is required, right? Similarly, if I talk about 3D motion, right? Spatial motion. Spatial comes from space, right? So when I talk about 3D motion, I'll say that, see, motion of the ball. So here you can see that at any given instant, if I want to specify the position of the ball, I will need 3 different informations, right? I will need to know where it is along x-axis, where it is along y-axis and where it is along z-axis. Make sense? All right. This is one thing. We need to understand what dimension is. Of course, 1 dimension, 2 dimension, 3 dimension, 3 types of motions that we have. The next thing that we talk about before studying any kind of motion will be the frame of reference, right? Frame of reference as in, where is your 0 point? Okay, so frame of reference is the frame attached with the observer. Who is observing the motion? Okay, so your your observation will depend on who is observing the motion. If the observer is standing on earth, standing on ground, that same motion will look different. If that same observer is going on an airplane, right, then the motion is going to look different. So, what is frame of reference? Frame of reference consists of 3 things, okay? First, the reference point. Generally, what we take as origin of the coordinate axis, right? The reference point, the point from where all the measurements are being made, all right? Then comes the coordinate axes. Coordinate axes as in, yes, set of 3 mutually perpendicular axes that tells you how to measure distances from the origin, right? We need 3 coordinate axes. What else do we need? We need a time reference, right? Think about it. We need a stopwatch. Say, right now if I start observing a certain motion, then I'll start the stopwatch right now and say this is t equal to 0 right now. Okay? And then say after 10 seconds, I am looking at its speed or velocity or displacement for that matter, then this is my time of reference, right? Exactly. So we need 3 things. 1, reference point, which is origin of the coordinate axes. Second, we need 3 mutually perpendicular axes. And the third thing, we need a time reference. All these combined tell you about the frame of reference. Okay. Now let's move on and see what is motion in 1 dimension, what happens here, right? So, in motion in 1 dimension, the particle is constrained to move in a straight line. Particle will always move in a straight line and it can only change its direction of motion opposite to the original direction of motion, right? Make sense? Particle will only move in straight line, and if it ever has to change direction, it can only reverse, right? Not turn left or right and so on and so forth. Make sense? Okay, okay. Now look at these animations. You will get a really good idea, okay? So I've got this black ball and see, this black ball is going along this horizontal line. Do you see this? When it turns, it goes back. The red ball, vertical line. And this is a blue ball that is going along this slanted line, right? So now when I talk about motion in 1 dimension, that line can be along any line, right? Its path, it can be along any line. As long as its path is along a line, it's a straight line, it's going to be linear 1 dimension motion. Okay. Ishika says like a pendulum. Ishika, no, not like a pendulum. In case of a pendulum, see, it becomes circular, right? What happens in case of a pendulum? In case of a pendulum, it becomes like this. This is how the motion happens. And here, it is not a straight line. Make sense? We need the particle to be moving in a straight line, whatever direction it is. It needs to be in a straight line. Then only it's linear. Make sense? Okay. Hello Ajmeri. It's great to have you here. All right. Okay, Ishika, you understood. Okay. Next thing, we'll talk about position. Okay. So how do we measure position in motion? Yeah. First things first, as I told you about, right? Anything, if you want to measure it, you will need to have a 0 point, right? A reference point. Say if you measure mass also, right? On the weighing machine, if you measure weight, you have to have a 0 somewhere, right? Similarly, on a scale as well, if you want to measure, say, length, you need to have a 0 somewhere. Same way, if I want to measure position of a particle, I need to have a 0 point, right? So here, if this is 0, then with reference to this 0, I can find out the position of the particle. I'll say that if the particle is moving on this particular axis, right, along this line, then we'll have 1 positive direction, 1 negative direction. And if the position is in the positive direction from the 0 point, we'll call it Yes, it's on the positive x-axis, and if it is a negative side, then it's on negative x-axis. Makes sense. Now, let's talk about distance. Distance traveled, right? Distance traveled is the total length of the path covered by the particle, right? So, for whatever time duration you are observing the motion, how much length of the path has been covered by the particle, right? Traveling from initial to final position. That is distance traveled. What about displacement? Displacement is a vector quantity, right? Now a vector quantity, you know already, vector quantity has magnitude, it has direction also, right? So for displacement, displacement is a vector from initial to final position along the straight line, right? So you take the initial position, you take the final position, you join them, the vector going from initial position to final position will give you displacement. Very simple, right? Okay. I'm pretty sure you guys know this already, right? Now, let's go to position vector. So, what is position vector then? Now, here we know what position is, right? Relative to a reference point, we know what a vector is. So now, when we talk about position vector tells you about position of the particle relative to the reference point, okay? It represents the position of a point in magnitude and direction because it's a vector, right? With respect to origin of a coordinate system called the reference point, right? So this is called position vector. Okay. Now here, if I talk about this coordinate axis, this is the origin, this is point P. So of course we take a vector from origin to point P, right? This vector going from the origin to point P, this vector is the position vector of point P. And if the coordinates of point P are x, y, z, then the position vector will be xi cap plus yj cap plus zk cap. Okay? Alright. Alright. Hello Sanjay, good afternoon. I hope you're understanding everything, right? Okay. Now, let's come to displacement vector. So what about displacement vector then? Displacement vector goes from initial position to final position, right? So let's say the point was earlier at point P, right? The particle was at point P. Now the particle is at point Q. So initial position is x1, y1, z1. Those are the coordinates. Finally, x2, y2, z2. And when we calculate vector from P to Q, this is displacement vector. And how do we calculate that vector? Displacement vector will be nothing but position vector of the final point, right? Final position vector minus initial position vector, right? Final position vector minus initial position vector, I can write it here. S vector is equal to R2 vector minus R1 vector. That's it. R final vector minus R initial vector. Now, when you subtract vectors, you know how to subtract it, right? X coefficient minus X coefficient, Y coefficient minus Y coefficient, Z coefficient minus Z coefficient. That's all. So, here we go. This is what displacement vector comes out to be when you know the position vectors. Very simple, right? Okay. Whose initial point is at origin and final point is at some ordered pair? Zishan says. Alright. Zishan, what are you talking about? Initial point is at origin, I understand. Final point will be at, yes, its position, right? That's position vector, of course. Some ordered pair, that ordered pair will be the ordered pair of coordinates. Not really pair, it will be an ordered triplet, right? You're talking about coordinates, x, y, z. Okay. Ishika, when will we take unit and dimensions? We'll take it after mechanics, alright? Okay. Units and dimensions along with error calculations, right? Now, we have understood the basics. You understand all of this. Let's apply these concepts in questions. Okay, so come on guys, gear up, solve this question, and here we go. A boy starts from his home and walks for 500 meter due south. Alright, so this is a boy, his path is given to you. 400 meter due west and 200 meter due north to reach his school. There are two things that are asked of you. What is the distance covered by the boy, and second, the displacement from his home to school, right? You know how to calculate distance and displacement. Come on guys, quickly solve this. Quickly give the answer in the chat window. Yeah? Come on. Boy starts from his home, walks for 500 meter due south, right? And then 400 meter due west, and then 200 meter due north. Now, when distances are given in this kind of a scenario, right? West, south, north, then we take the help of direction coordinates. Okay, so first let's get direction coordinates and then we will understand how the distances are. What is the path traveled, right? Okay, let's make the figure. Here I can see that, well, this is the direction coordinates, north, east, west, south, and here we go. If he starts from home and goes to school, the first distance that he goes or the first displacement that he has is in the south direction. So he goes 500 meter south, right? Then he goes 400 meter due west, all right? 400 meter due west. Do you see this? Then he goes north. North means over here, but only 200 meter, right? So here we go. This is initial position. This is the final position. What do we want? We want two things, distance traveled and displacement. Come on guys, tell me, what is the distance traveled coming out? Very quick calculation, right? Distance traveled is, yes, 500 plus 400 plus 200, right? Distance traveled is magnitude of the first displacement plus magnitude of the second displacement plus magnitude of the third displacement, right? We want to add up length. So here we go. 500 plus 400 plus 200 gives you 1100 meters. That is the distance traveled. What about displacement? All right, correct. Soumya and says 500 meter displacement. Garima says 500 meter. Now the thing is, guys, you got the magnitude correct. Displacement is a vector quantity. Come on, tell me the full value of displacement with magnitude and directions. Okay? Right. Displacement magnitude is 500 meters. Kiran, Pushpa, correct. You also got this. Okay. I can see Priya has also got 500 meters. What about direction though? How do we find direction? We'll say that the direction of displacement will be from initial position to final position. This is the vector, right? This is the vector of displacement. And how do we write its direction? We will say that this much, see, this distance will be 500 minus 200, which is 300 meters, and this distance will be 400 meters. So now I've got a right angle triangle. These are the two sides, perpendicular sides, 300 and 400. So the third side will be 500 meters, right? 3, 4, 5, right angle triangle. Very quick. Direction, yes, we can calculate direction as well, and we can say that, see, this is a direction, right? This is 3, 4, 5 triangle. So this angle over here will be 53 degrees, right? Okay, tan inverse 4 by 3. Let's go there. So here if I say that, yes, displacement comes out to be 500, right, magnitude. If I want to write the displacement in terms of I cap and j cap, I can do that as well, right? I can say that, yes, this is the minus j cap direction. This is minus I cap direction. Here we've got 300, here we've got 200. So minus 300 I cap minus, 400. So minus 300 minus 400 I cap minus 300 j cap, right? We got that much. Now if we talk about angle, so here we've got 3, 4, 5 triangle. This is 300, this is 400, this is 500. This angle comes out to be tan inverse 4 by 3, which is 53 degrees. And we say the direction is 53 degrees west of south. Yes, correct. Kiran says 53 degrees west of south. All right. There we go. Now that we've got a really good idea of distance and displacement, let's talk about the next thing about motion, right? Next parameters of motion, which is, yes, speed and velocities, right? So we'll go for average speed, average velocity, then we'll talk about instantaneous speeds and instantaneous velocities. Make sense? All right, let's go. Here we go. Average speed and average velocity. Now what are those? Okay. To understand average speed and average velocity, we need to be very, very clear about distance and displacement first, right? All right. So on this map, if somebody is going from say Delhi to Lucknow, right? The distance traveled will be the length of the entire path that is taken. Okay. This is the distance traveled. All right. You use navigation on your map, right? I use it a lot. We always get road distance as well, and we get aerial distance as well. You understand that, right? When you take up the map and you search for some place, right? I'm searching for say Bangalore airport. Then the first distance that I get is the aerial distance, and then when I go for directions, when I actually look on the map for directions, then I get the distance along the route, right? Yes. So here we go. This distance along the route, the length of the path is the distance traveled, and the other thing that the map tells you, right? This length of the straight line joining from initial position to final position, this aerial distance that we call it, right? That is displacement, right? This is displacement. And once we understand what distance and displacement are, we can easily understand what average speed and average velocity are, because if delta t is a time taken for the particle to go from position A to position B, then length of path divided by time taken gives you average speed. Alright, average speed of a particle over a certain time interval is defined as the ratio of total length of the path traveled to the time interval. That's it. So distance covered divided by time taken. What about average velocity? Yes, Indian Railway says, ma'am, shortest distance is displacement. Yes. Shortest distance between or shortest line joining initial position and final position is the displacement. Alright. What about average velocity? Here see, in case of average speed, we are taking the length of path, distance traveled divided by time taken. In case of average velocity, it is displacement upon time taken. Okay? Alright. Displacement upon time taken is average velocity. So again, now the thing is, since displacement is a vector quantity, see here, displacement is a vector quantity. So vector quantity divided by scalar, which is time, right, gives you another vector quantity, and that is why velocity is a vector quantity, right? Average velocity is going to be a vector quantity which is equal to s vector divided by t. And if we talk about speed, speed is a scalar quantity. Okay? Alright. Now that we have understood what average velocity is, what average speed is, how to calculate average velocity and average speed, let's go to the next thing, which is instantaneous speed and velocity. Right? So what is instantaneous speed? Now, I'm pretty sure you guys have, well, traveled in some motor vehicle or the other, right? Whether you're traveling in a car or you're traveling on a motorbike, you will see the odometer, right? Speedometer also we call it. Speedometer mein kya dikhta hai? You see the instantaneous speed in the speedometer, right? At that particular instant, at that particular moment, what is the speed with which you're going? Is it 60 km per hour? Is it 70 km per hour? And so on. You can see that as it moves, you see the speed at that particular instant. That is instantaneous speed. Okay? Instantaneous rate of change of distance with respect to time is called instantaneous speed. That means distance is anyway changing, right? Path is being covered. So the rate at which path is being covered, the rate at which distance is being covered is instantaneous speed at that particular instant. Okay. So when you're accelerating, instantaneous speed keeps increasing. If you brake suddenly, instantaneous speed drops, right? All right. How do we calculate it? We can calculate it. Instantaneous speed is equal to ds by dt, which is the path, right? Okay. This s over here is actually mod s, length of path, okay? ds by dt. Now, when we talk about instantaneous velocity, on the other hand, right? Instantaneous velocity is, yes, just like instantaneous speed. Instantaneous speed talks about rate of distance covered. Instantaneous velocity talks about rate of displacement, right? Okay, so instantaneous rate of change of position with respect to time, right? How does displacement happen? Displacement happens because particle's position keeps changing, right? So Rate of change of that position will give you velocity. Instantaneous rate of change of that position will give you instantaneous velocity. Make sense? All right. So instantaneous velocity is, yes, d s by dt. S is displacement here, right? Okay. Now that we understand this, let's solve questions now, yeah? Because as you understand, right, the fundamentals are very simple. Fundamentals are not much. Their applications are what that matter. So quickly, come on guys, read this question, quickly solve this question, and let's see how we are applying this, yeah? Okay. Here we've got a question. A man is walking. Man walks on a straight road from his home to the market 2.5 kilometers away with a speed of 5 km per hour, right? So home to market, it is 2.5 kilometers. Finding the market closed, he found the market closed. He instantaneously turns and walks back home with a speed of 7.5 km per hour, right? He immediately turns back and starts walking back. The average speed of the man over the interval 0 to 40 minutes is equal to how much? Okay, that is what is being asked. Average speed over the interval 0 to 40 minutes. Come on, quickly solve this. Quickly tell me what are you getting in the chat window. Yeah. So here you can understand that it's not given that he comes back home completely, right? No, he might be somewhere in the middle of coming back as well. We need to figure that out. All right, let's see. What is happening here? First things first, average speed, right? Average speed is what? Total distance upon total time, right? We want to calculate average speed, total distance upon total time. The time taken in total is 0 to 40 minutes. We just need to figure out how much distance did he travel in these 40 minutes, right? Okay, so how do we start? We start by figuring out where is he at 40 minutes, right? Because he started from here at t equal to 0. Went to the market, while returning, he must be somewhere along the way when 40 minutes happened, right? Okay, so let's figure it out. Now, going forward, we can say that, well, to go from home to market, it's 2.5 kilometers away, right? Time taken will be equal to 2.5 kilometers, distance upon speed. Speed was 5 km per hour. That gives me half an hour, right? Okay. Half an hour means 30 minutes. It took him 30 minutes to reach the market. But see, the thing is here, we are asked to calculate average speed from 0 to 40 minutes. So if it took him 30 minutes to reach the market, that means how much time did he spend coming back? On the return journey, he spent, yes, on the return journey, say he is at this position R right now, I will say that going forward, he spent 30 minutes. Coming back, he will spend total of 40 minus 30. Yes, remaining time is 10 minutes. 40 minus 30. Okay. So now I want to figure out total distance, right? Total distance upon total time. Total distance will be this 2.5 kilometers that is going forward plus how much did he travel in these 10 minutes, right? From home to market, home से market तक तो 2.5 travel किया, but वापस जाते समय कितना travel किया? That will be, yes, distance traveled in 10 minutes, and while coming back his speed is 7.5 km per hour. So now I will say that, all right, returning time, right, while returning, time is 10 minutes, speed is 7.5. So how do we calculate distance? We will say that the returning distance, this distance that he traveled, right, from M to R, that will be equal to speed into time, which is equal to 1.25 kilometers. Right? Time, you see that since speed is in kilometer per hour, we have to keep time in hours. So 10 minutes equal to 1 by 6 hours. And once we substitute the time, we say that, okay, this much distance traveled, that means 1.25 kilometers traveled back, right? So now we have total distance. and we have total time. Tell me quickly, what is the average speed? Come on. We have total distance, right? Total distance is equal to going forward 2.5, coming back 1.25. Okay. Average speed will be equal to total distance divided by total time, 2.5 plus 1.25 divided by total time, which is, yes, 40 minutes. Now instead of substituting it in minutes, I will substitute it in hours. So 40 by 60. Make sense? Yes, Ishika gave the answer 45 by 8 km/h, which is correct. 45 by 8 is the answer to this particular question. Good job, Ishika. I hope a lot of other people also got the answers, right? आप लोगों को समझ में आ रहा है कैसे हो रहा है? Okay. So what did we do in this question? First off, we figured out, well, we want to find out average speed, मतलब total distance चाहिए, right? Going forward, it took him 30 minutes. Going back, it took him 10 minutes. Corresponding to these, we calculated distances, right? So, going forward, distance was already given, 2.5 kilometers. Coming back, we calculated this distance using the coming back speed. And then, we added the both distances. That gave me total distance. Make sense? Alright, alright. Let's move on now. Here, we have talked about average velocity, average speed. Let's talk about average acceleration also. Okay? So, what is average acceleration and instantaneous acceleration for that matter? Right? Now, before learning about it in physics, come on guys, tell me. Had you heard the word acceleration before you read, say, 8th, 9th standard? Come on. I'm pretty sure you had, right? Yes. Whenever you travel in a motor vehicle, again, whether it's a car or it's a bike or it's a scooty or anything for that matter, आप क्या करते हो? You accelerate, right? This is how you accelerate in the scooty and this is how you accelerate in the car. But what does that acceleration mean anyway? Come on, you'd heard it, right? What happens when you accelerate? Bike, scooty तो बहुत लोग चलाते होंगे आप लोग, right? So what happens when you accelerate? It goes forward. Yes, it increases the speed, right? Exactly. So now I will say that let's bring it in physics. Yes, it increases the speed. Practically, that's what we understand. But the thing is, when we bring it in physics, we'll say that acceleration is actually rate of change of velocity. Not only increase but decrease of not only speed or not speed but velocity. Okay. So instantaneously what happens is instantaneous speed is nothing but magnitude of instantaneous velocity. Right. Think about it. Odometer mein agar 60 km/h it's showing and you're going north, right? In odometer, if it is showing at any given instant, say 60 km/h and you're going north, then at that particular instant, instantaneous velocity is 60 km/h north and instantaneous speed is 60 km/h just, right? So when we talk about instantaneous, magnitude of velocity is just instantaneous speed. Now, when we talk about acceleration, if we are changing this speed, if we are changing the velocity, the speed automatically changes, right? Yes, and that's what accelerator does, right? So when I increase acceleration in the direction of motion, I will say that, yes, the velocity increases and thereby consequently speed also increases. So आपको क्या मिलता है? You go faster, right? But then if I brake also, what am I doing? I'm applying acceleration again in the reverse direction. Right? When I'm braking that car or braking that bike, I am applying acceleration in the reverse direction. So then velocity decreases and thereby speed decreases. Make sense? So when I'm defining acceleration, I will always define acceleration with rate of change of velocity. So if acceleration is rate of change of velocity, then average acceleration will be average rate of change. Right? That means change in velocity divided by that time interval, delta V by delta T, right? And if I talk about instantaneous acceleration will just be rate of change of velocity with respect to time at that particular instant. Make sense? Tell me if it makes sense. Alright? Okay, T-Series official says NCERT example also. Cover. Alright, yeah. We'll be doing NCERT examples as well. We'll be doing relevant questions. Alright. So, okay. So when we talk about instantaneous acceleration, we'll say that yes, it is instantaneous rate of change. Now, when we talk about instantaneous rate of change, it is nothing but d by dt, differential of velocity with respect to time, right? So dv by dt. Limit delta t approaches 0, delta v by delta t, that is the instantaneous rate, right? How do we get that? For any time interval, if I take that time interval and calculate average, I will say that delta v by delta t will be average acceleration for a given time interval. Now if I keep reducing that time interval, right, making it shorter and shorter and smaller and smaller and smaller, then I will say that limit delta t approaches 0, delta v by delta t, this is nothing but differential of velocity with respect to time, dv by dt, instantaneous rate of change at that particular instant. Okay? Now, let's move on. Let's solve a question. Let's apply what we just learned. Okay? So, here's a particle initially moving towards east with 50 meter per second. Takes left and moves along north 50 meter per second. Right? In an interval of 1 second. So, initial velocity is given to us. Final velocity is given to us. Time interval is also given to us. What is the magnitude and direction of its average acceleration? That's what is asked. Okay, magnitude and direction of average acceleration, because as you understand, acceleration is also a vector quantity. Now, quickly calculate and quickly tell me what's going on. What's the answer? Ishika asks, ma'am, integration differentiation nahi lenge kya? Okay, so we'll have one separate session for basic maths. Alright, I understand that you guys are might face difficulties in application of basic math, right? So we'll have one separate session for that, right? But that will be outside of our regular mechanics that is going on, okay? Alright. So, what do we do here? We want average acceleration. What is average acceleration? Delta v by delta t, right? And we know initial velocity, we know final velocity, we can calculate delta v, right? Yes, we can. Let's solve. Here we go. Average acceleration is nothing but delta v by delta t, which is v final minus v initial upon t final minus t initial, right? Now, time interval is already given as 1 second. Alright, how do we calculate delta v? Delta v is v final minus v initial, and this is vector subtraction, right? So let's look at the graph, let's look at the plot here, right? We have taken direction coordinates, we have plotted the vectors. This is initial velocity vector, this is final velocity vector, right? Now, if I am subtracting final velocity vector minus initial velocity vector, what do? I will take final velocity vector as it is, but reverse the initial velocity vector's direction. So this is my reverse of initial velocity vector, this is minus vi vector, right? And then I will add them up. So this is the resultant. Here we go. Now what is this telling us? This is telling us that this is the delta v vector, right? Delta v, and to calculate acceleration, we just need to calculate delta v and then divide it by 1 second. That's all. So tell me, 50 root 2, yes, magnitude is 50 root 2. So what do we get? Vf minus Vi, as you can see, this is 50, this is 50. So root over of 50 square plus 50 square, 50 root 2. Acceleration magnitude will be just 50 root 2 divided by 1, that is 50 root 2 meter per second square. That is good. Direction? Yes, you can see in the figure, right? What is the direction? Alright, yes, it is northwest, right? This is the direction. Come on, this is the direction of delta V. So, if acceleration is delta V by delta T, then whatever the direction of delta V vector is, same direction will be of average acceleration vector. Make sense? So, here we go. This is the direction. And what is the direction? Northwest, right? So direction is northwest. Okay. I hope you guys understand this properly, right? Zishan says north of east. No. North of, it will be northwest. Okay. Now, okay, I have a question here. Why reverse velocity? Right. So Sridha, the thing is, when you are subtracting vectors, no, when you are doing A vector minus B vector, right? The second vector that you have, you would have to reverse its direction to get minus B vector, and then we can say this is equal to A vector plus of minus B vector, right? This is what we did. Final velocity minus initial velocity. So what did we do? We wrote minus Vi vector, which will be in the reverse direction of the initial velocity vector, and then we just added these two vectors, right? Took their resultant. That's all. Okay. Now I hope everything is clear, right? This is how we do vector subtraction, right? Okay. So this is V final vector. Over here, this is negative Vi vector minus Vi vector, and then we take resultant of these two, we get delta V. Alright. Here we go. Another question. Come on, guys. Let's properly solidify how to apply these questions and concepts into questions. Okay. Average acceleration of the object over time interval 2 second to 4 second will be how much? And here we have, yes, here we have VT graph. What will be the average acceleration of this object over this time interval? Come on. First things first, we have 4 options: 4 meter per second square, 2 meter per second square, 8 meter per second square, and 9 meter per second square. Quickly solve this question. Quickly tell me, what is the answer? Abhay says B. Alright, Abhay. Anybody else? There are no calculations over here. Okay, very, very quick. No complicated calculations. You just need to look at the graph and see what's going on. And don't worry about it. If you're thinking, ma'am, my graph is a little bit weak, don't worry about it. We will come to graph and we will solve more graph questions as well. Okay? Here's just a teaser. Because, well, we are revising, right? Yeah. So, I can give you teasers. Alright. So, here, Priya says B. Great. Alright. Avantika says B. Kiran says A. Okay. Zishan says 4 meter per second. Beta 4 meter per second square hoga, right? Because acceleration, it has to be meter per second square. Alright. So, B, A, C, I can see a lot of people answering. Kiran, Shubham, Archana got B again. Alright. Let's see. So, what is acceleration then? Acceleration is rate of change of velocity, right? Okay. So, A vector is delta V by delta T. Now, when I talk about delta V by delta T from 2 second to 4 second, it will just be from here. See, 2 second is over here, 4 second is over here, and delta V by delta T. What is the value of delta V? Delta V is this, delta T is this, right? Yes. I'm going to use another color over here so that you see this properly. Okay. This is delta V and this is delta T. We have the values. What is the value of delta V? 10 minus 6. There we go. 10 minus 6 divided by 4 minus 2. How much is this? Yes, 4 by 2, which is 2 meter per second square. There we go. And do you see that this divided by this is nothing but delta V by delta T, which is nothing but tan theta in this particular triangle, which is nothing but slope of this straight line. And as you already know, right, in velocity time graph, slope of the graph gives you acceleration. So there we go. Average acceleration is of course equal to instantaneous acceleration over here because it's a straight line graph, right? Yeah, uniformly accelerated motion. So whether you calculate slope over here or over here or over here, everywhere slope is the same. And so average is equal to instantaneous. Great. Yes, B is the correct answer. All those who got B, correct, you guys were correct. Okay. And those who did not, did you understand how we solved this question? All right. I hope you did. And with this, we are going to the next part of this chapter, right? Motion in one dimension, which is uniformly accelerated motion in one dimension, right? Uniformly accelerated motion is very, very simple to solve. All you need is, yes, 3 equations of motion. That's all. To understand how to apply 3 equations of motion. That's all. Okay? मैम अगर हिंदी मीडियम चूज करें नीट एप्लीकेशन फॉर्म में तो क्या पेपर ओनली हिंदी में आएगा क्या, और क्या हिंदी मीडियम मेडिकल कॉलेज मिलेगा? बेटा मेडिकल कॉलेज का मीडियम मेडिकल कॉलेज पे डिपेंड करता है, बट या इफ यू चूज हिंदी मीडियम तो हिंदी मीडियम में आएगा पेपर. ओके, एंड मोर अबाउट नीट पेपर आपको हम एक अलग सेशन में बताएंगे. ठीक है, हाउ टू फिल द फॉर्म फिल करोगे तो क्या मिलेगा क्या नहीं मिलेगा, एंड सो ऑन एंड सो फोर्थ. ओके, alright. Now if I talk about this ball which is undergoing uniform acceleration. Uniform acceleration मतलब acceleration constant है. Acceleration is a vector quantity मतलब इसका direction भी constant है, magnitude भी constant है. Okay, both direction and magnitude are constant. Now if there is a ball going from initial velocity, say at t equal to 0, its initial velocity is u, at t equal to t, its final velocity is v, and in this time interval from 0 to t seconds, it covers s displacement, right? It goes from initial position to final position. Then here are the 3 equations of motion that you have been studying since 9th grade, and you have used them a lot, right? Okay, so application of these 3 equations of motion is really important. So we'll go quickly over to applications. All right, first is v equal to u plus at, second is s equal to ut plus half ad square, third is v square equal to u square plus 2as. And yes, these are vector equations. So of course, when you substitute these values, you will have to take one direction as positive, the other as negative, and substitute according to direction. Okay? Alright, here as I just said, u is initial velocity, v is final velocity, s is displacement, a is acceleration, t is time duration of the motion that we are observing. Okay? And make sure all of these values that you have calculated and you are substituting is with respect to the same frame of reference. Alright? We'll talk more about frame of reference when we come to motion in 2 dimension, but here as well, I want to make sure you understand that whenever we calculate anything, whenever we apply any of the motions, any of the equations, any of the concepts, we will observe motion with one particular frame of reference. Okay? Alright. And yes, of course, these equations of motion always are only applied in uniform acceleration. Acceleration constant hona chahiye. Now, here we go. This is a question. An object moving at 8 meters per second accelerated at a constant rate of 5 meters per second square. The velocity of the object after 10 seconds is. Come on guys, tell me what the answer here is. It's a very, very simple application, very quick. Quickly give me the answer. It should not take you more than 10-15 seconds to solve this question. Come on, maximum 15 seconds. It should not take you more than that. Quickly tell me what is the final velocity. Yes, Kiran. Kiran got 58. Alright, correct. Shubham, yes, 58 meters per second. Correct. What are we doing here? We have initial velocity, we have acceleration, we have time duration, right? U is given, A is given, T is given. We will substitute it in first equation of motion, V equal to U plus AT. Here we go. 58 meters per second. Very, very simple, right? All right. Okay, we get this. Now, there is another thing that comes, right, in uniformly accelerated motion. Another thing that is very, you should know how to calculate it, right? Which is displacement covered in nth second. Now, what is displacement covered in nth second? Think about it this way. Say a particle is traveling, right? From 0 to 1 second, right? There would be certain distance covered, some displacement covered. From 2 to 3 seconds, there will be some displacement covered. From 3 to 4 seconds, there will be some displacement covered. That is what we're talking about, right? Displacement covered in nth second. in second of motion or in 5th second of motion, how much displacement is covered. Now, in general, right, while solving questions, you can think about it this way, right? Simple concept. Say a particle keeps traveling in a straight line. Say at t equal to 4 seconds, right? Let's say he started from here, right? This is t equal to 0. Let's say at t equal to 4 seconds, the particle is over here, and at t equal to 5 seconds, the particle is over here. Then can I say that the displacement covered from 4 to 5 seconds, that is displacement covered in 5th second, will be nothing but displacement in 5 seconds minus displacement in 4 seconds, right? Yes, that is logic, that is common sense. Whatever distance is covered from 0 to 5 minus distance covered from 0 to 4 will give you this much rest of the distance covered, right? Or rather displacement. Since it is traveling in a straight line, not changing direction, we can say that both will come out the same, but by fundamentals, yes, displacement will be S5 minus S4. Now, if we apply the same fundamental generally and say that instead of in 5th second, what if I have to calculate in nth second? Then also I will apply the same fundamental. I will say that S equal to ut plus half a d square. You know this. If I substitute t is equal to n, then it gives me displacement covered in n seconds. If I substitute t equal to n minus 1, it will give me displacement covered in n minus 1 seconds. And if I subtract Sn minus Sn minus 1, it will give me a displacement in nth second, right? That's about it. So, if I substitute and actually subtract these two, right? This first equation minus second equation and calculate, I get a relation which comes out to be equal to Snth is equal to u plus a by 2 into 2n minus 1. And it is good to remember this. Alright? Okay. Displacement in nth second, u plus a by 2 into 2n minus 1. Now, there are a lot of questions that are asked which are simple applications of these equations of motion, right? And we've already done 3 equations of motion before. So this one I'm going to call as 4th equation of motion. That fine? Okay. Here we go. Let's solve a quick question and then we'll move on. Okay? Application of what we just learned. Displacement of a body in the 4th second of its motion is twice the displacement in its second second. Okay? If the acceleration of the body is 3 meters per second square, what is the initial velocity? Is what they're asking. Okay? Come on, tell me what is the answer that comes out. Here we're talking about displacement in 4th second, displacement in 2nd second, and there is a relation between them. Right? We have to find out what is the initial velocity. Acceleration is uniform. It is given as 3 meters per second square. Come on, quickly give me the answer. What is the answer? Again, here as well, it should not take you more than 30 seconds to calculate here. Okay? Very simple calculations. You just need to apply the formula. You just need to apply the relation. All right. So, what is the relation that we're applying? Yes, Snth is equal to u plus a by 2 into 2n minus 1. And the relation that's given in the question is, see, displacement of body in 4th second, right, S4th is twice the displacement in 2nd second, 2 times S second, right? There we go. So what do? See, we calculate these values separately, S4th and S second, and then we substitute it in this equation. Make sense? Okay. Now, let's do that. Alright, Kiran got an answer already. U is 1.5 meter per second. Alright, let's see what comes out. Come on, everybody else. Quickly calculate, quickly give me the answers over here. What are you getting? Initial velocity value, what does it come out? Medellina also got 1.5. Okay. Anyone else? 1.5 meter per second, huh? Alright, let's see what it comes out. Come on guys, quickly calculate. I'm not telling you the answer right now. Okay. S fourth and S second, that's what we need to calculate, right? Let's do that. So S second will be nothing but substitute n equal to 2 in the same relation, right? U plus a by 2 into 2n minus 1, a is 3. There we go. S second is u plus 9 by 2. And S fourth is again substitute n equal to 4. So u plus 21 by 2. Alright, we have this. The only unknown is u. Let's just substitute in the equation. Alright, here we go. S second is u plus 9 by 2. S fourth is u plus 21 by 2. If I substitute S fourth is equal to 2 times S second, we get u plus 21 by 2 is equal to 2 times u plus 9 by 2, which is this. Here we go. 2u minus u gives me u. Taking the numbers on the LHS, u on the RHS. Here we go. 21 by 2 minus 18 by 2, that is 3 by 2 meter per second. 1.5 meter per second. Correct. Those who got 1.5, good job, guys. I can see Janvi also got, and Danyalal. I'm sorry if I'm pronouncing your name wrong. All right. Hello, Abhishek. You also got 1.5 meter per second, is it? Okay. All right. Now, let's move on and let's talk about motion under gravity. All right. One-dimensional motion under gravity. Now, see, the thing is, when we talk about motion under gravity, right, say if I take this pen, right, and I throw it up. I'm not going to throw it up right now because it's going to break. But yeah, if I take it and if I take a ball and throw it up, what's going to happen to it? It's going to go up, come to rest at certain point and come back, right? That's what's going to happen. Why? Tell me, guys. Why? Because of, yes, acceleration under gravity, right? Okay. Acceleration under gravity is 9.8 meter per second square. Come on, you guys know this, right? What is the value of g? Motion under gravity is because, yes, Earth pulls everything down. Earth pulls all the masses down. We have learned about Newton's law of gravitation. And yes, for smaller distances, right? If distances are very, very small compared to radius of Earth, we can take acceleration due to gravity as approximately a constant value. And acceleration due to gravity is g vertically downwards. Value is approximately equal to 9.8 meter per second square. Okay. Now, see here. Here as well, if I have motion happening, if I throw the ball vertically upward, it is going to travel upward and come down along the same line. That means I have a motion in one dimension. And I have motion in uniform acceleration, right? So, whatever we learned about motion and uniform acceleration, all three equations, they will be applicable here as well, right? The only thing is that if I take upward direction as positive, downward direction as negative, then acceleration is always going to be equal to 9.8 meter per second square and vertically downwards, which is negative. That's all, right? So, if I take my equations of motion and just replace A with minus G, then I'm going to get the same thing. I'm going to get V equal to U minus GT, H is equal to UT minus half GT square, and V square equal to U square minus 2GH. There we go. Nothing new. Alright guys, what we're doing is, we're just taking another motion in uniformly accelerated, uniform acceleration. That's all. Okay. Take A, replace it by minus G. That's all. Why minus G? Because upward is positive and downward is negative and G is in negative direction. That's why. There we go. Now, here I've got a question. Quickly solve it. Quickly tell me what's going on. Alright. Particle is thrown up with a velocity of 30 meter per second. Find time of flight, maximum height reached by the particle, landing speed of the particle, and assume acceleration due to gravity is 10 meter per second square. 10 meter per second square, a lot of times we take because if you want to reduce our calculations. Alright. In the questions also, a lot of time it will be given to you. So, quickly tell me if a particle is thrown up with 30 meter per second velocity. With what velocity will it fall down? Same speed with which it was thrown up, right? Yes. All right, Ramesh. This is here. I'm teaching and motivating. Guys, quickly solve this question. Tell me what comes out. Come on. So, what happens here? First things first, if I talk about time of flight, how do we define time of flight? Think about it this way, flight, right? So, till what time is the object flying? Is it in air, right? That's what is time of flight. Kitni der tak object hawa mein hai? So, it's going up and then it's coming down, right? So, T up plus T down. T up plus T down. That's what is time of flight. And in case of uniformly, in case of motion under gravity, if I take a ball, right, and throw it up with you, it's going to go up, take certain time, come down to ground with same amount of time. Okay, so time taken to go up is equal to time taken to come down. And you can actually apply the three equations of motion and get it. Alright, I'm giving you the distilled version over here. So, time taken to go up is always equal to time taken to come down if the ball is coming back to the same position from where it was thrown up. Okay, and if I want to calculate the landing speed, then also, whenever you throw a ball up with a certain speed u, by the time it reaches back the same position, it is going to come back with the same speed u. Okay, just the direction reverses. Alright, so here if a ball is thrown up with 30 meter per second, it's going to come down with 30 meter per second only, and time of flight will be total time to go up plus down. Alright, now if I apply, yes, the same idea, v equal to u plus at, I'm going to say final velocity is in the negative direction, so minus 30, right? Or rather, final velocity is equal to minus u, this is equal to u plus at, initial velocity u plus at minus gt. What does t come out? T comes out equal to, see, 2u by g. And this is something that is, again, you can remember as a shortcut, and you can say that whenever we throw a ball up, it is going to take a total time of 2u by g to come back down to the same position, right? 2u by g is going to be time of flight. What about maximum height? Now see here, if I calculate maximum height, I can apply, yes, v square equal to u square plus 2as. Final velocity as you go up is going to be equal to 0. At the highest point, ball attains 0 velocity, right? So v equal to 0, u we have already, right? U is 30 meter per second and g is vertically downwards. So what do we get? Yes, 0 is equal to u square minus 2gs. Here we go. H comes out equal to u square by 2g. See? U square by 2g. And this again is another short relation that you can remember and say that whenever you're throwing a ball up, highest height that will achieve will be equal to u square by 2g. Okay? Alright, and now if we substitute these, if we calculate, what do we get? Yes, time of flight comes out to be a total of 2u by g, which is 6 seconds, right? And highest distance traveled, or rather highest height achieved, will be equal to u square by 2g, which will be equal to 30 square divided by 2 into 10, which is 45 meters. Correct? Okay, Shubham got 45 meters. And let's move on. The third thing that was asked was just landing speed. 30 meter per second से throw up करोगे तो 30 meter per second से नीचे आएगी. That's all. Alright? Okay. Let's move on now. Let's go to graphs in kinematics. Alright? Another very interesting thing. Alright? Interesting concepts in kinematics, which is graphs in kinematics. Alright. I hope everybody understood this much. Now, when we talk about uniformly accelerated motion, right? Again, the concept is the same. We're talking about three equations of motion. Alright? And the fourth one, S and Nth. Now, applications and questions matter. So just guys, after this session is done, do solve a lot of questions, do practice. Alright? Especially the previous year's questions, and time yourself while practicing. Give yourself only 60 seconds per question. Okay? All right. Now, when we talk about graphs in kinematics, right? First thing, displacement time graph. Now, what does displacement time graph give you? See, if I have a displacement time graph, then slope of the displacement time graph is going to give me velocity, right? So, if I take a point, at this particular point, if I draw a tangent, then slope of this particular tangent is going to give me velocity at this particular time, which is at this time. Okay? And rate of change of this slope is going to give me acceleration. Alright? So, if I say initially, here itself, if I talk about rate of change of slope, that means just before this time, how was the slope, and just after this time, how is the slope? Okay? Come on, look at it carefully. Just before this time, if I take, say, I'll take another color and tell you, इस t के just पहले, okay, यहाँ पे से बहुत छोटे interval के पहले, if I say, then the slope was a little less compared to slope at t, right? And then if I go just beyond, then it's going to increase a little more, right? Do you see what is happening? Slope is increasing. If slope is increasing, that means velocity is increasing. That means rate of change of velocity, rate of change of slope is acceleration over here. Okay? And there is a very quick way of figuring out whether acceleration is positive or negative in any given ST graph. Alright, any given displacement time graph. If I have a graph like this, right, a very weird graph, ST graph, then if I want to find out if acceleration is positive or negative, all I have to do is look at the curvature of the graph. Okay, a very easy shortcut for you to remember. Okay, say I want to find out at this particular point. Yeah, so here do I see this kind of a graph, right? Concave upwards. Whenever the graph is concave upwards, means acceleration is positive. Whenever the graph is concave downwards, it means acceleration is negative. And there is a very easy way to remember this. In ST graph, concave upwards means smiley curve. Do you see this? And concave downwards means frowny curve. So, if it's a smiley curve, you're going to get acceleration positive, which is easy to remember, right? Smiley positive. And if it's a frowny curve, you're going to get acceleration negative and easy to remember, right? Negative frowning. Okay. This way, you will always be able to figure out where is acceleration negative, where is it positive. If it is not a part of smiley or frowny, right? If it is a straight line, then acceleration will be equal to 0. Okay? In ST graph, remember that. Alright, next we come to velocity time graph, VT graph, right? If I have velocity time graph, then do you understand that dv by dt is acceleration, right? Okay, so if dv by dt, rate of change of velocity is acceleration, then slope of VT graph will always give me acceleration, right? And again, here you can see that this is a straight line graph. That means constant slope. Constant slope means uniform acceleration, right? But if it's not a straight line graph, that means the slope is not going to be constant. It is non-uniformly accelerated motion. Okay? Alright. Now, when I talk about acceleration, you have understood, right? There are, yes, two ways in which we calculate acceleration. We say instantaneous acceleration or average acceleration, right? Yes. So, here as well I will say, if there is a graph, there is a VT graph and you're drawing tangent at a given point, right? You're drawing tangent at a given point and you're looking at slope of the tangent at that given instant. That will give you instantaneous acceleration, slope of tangent. Slope of tangent will give you instantaneous acceleration. But if I want to calculate average acceleration from T1 to T2, right? Then I will have to calculate slope of secant drawn from T1 to T2. Okay, so here we go. If I have T1 time over here and T2 time over here, let's say, and I want to calculate what is the average acceleration in the duration from T1 to T2. Then I will take this point over here, right, graph at T1, the value of velocity at T2, join these 2 points. This is what? A secant to the graph, right? Secant means line joining 2 points on the graph, right? Line passing through, line cutting through 2 points on the graph, right? So this is secant, and when we talk about slope of this secant, this will give me average acceleration. Okay? All right, that's about slope. What about area under the curve? Yes. See, since we have V is equal to ds by dt, I take it, reverse it, integrate. What do I get? Yes, this is a differential equation. Reverse of this differential equation will give me this integral ds is equal to v dt, integrate on both sides. This gives me area under the curve, right? Integral v dt is nothing but area under the curve of vt graph. This is integral ds, which is displacement, right? Integral ds is delta s. So displacement in a given time interval is equal to integral v dt from t1 to t2. Okay? All right, all right. Now that we've understood this, right? Let's talk more about area under velocity time graph, right? And let's see what all different types of graphs we generally see. Okay, so if we have this kind of a graph, right? Horizontal straight line graph, it means it's a constant velocity. If it is a constant velocity, then all I need to do is calculate area of this rectangle, which is how much? Yes, if we're talking from t1 to t2 and velocity is v, then here we go. This is the displacement, right? Instead, if I have a straight line graph, right, but not horizontal straight line at an angle, it means that here we've got a straight line with non-zero tangent, right? Non-zero slope. So here I can say that it's a uniform velocity, right? Okay. Non-zero tangent, acceleration is constant, uniformly increasing velocity, and here we go. Displacement in the first case will nothing be displacement of rectangle. In the second case, this will be displacement of the trapezium, and this is equal to half of v1 plus v2 into t2 minus t1, right? Half of v1 plus v2, addition of these two parallel sides into distance between the parallel sides, which is t2 minus t1, right? Okay. And if it is a general kind of a graph, not a straight line graph, then that means it's not a uniform velocity or not a uniformly accelerated motion, but it is a non-uniformly accelerated motion, right? Non-uniformly increasing velocity. In this case, you just have to integrate. Okay. Janvi is asking, ma'am, does area under velocity time graph give displacement? Yes, yes. Area under the velocity time graph gives you displacement. All right? Okay. Now, after we've done displacement time graph and velocity time graph, let's come to acceleration time graph. Okay. Now, what happens in case of acceleration time graph? Here we go. If I talk about slope of acceleration time graph, this will talk about rate of change of acceleration, right? Ma'am does, okay. All right. So, if we talk about acceleration time graph, we will say that we're talking about rate of change of acceleration will be given by the slope, and yes, integral a dt will be given by the area, right? So here we go again. Rate of change of acceleration, when we talk about, that is jerk actually, right? That we generally don't study in kinematics, at least not in your syllabus. So I'm just going to mention it here, right? Slope of acceleration time graph is jerk. But if we talk about area under the curve, that is something that is really useful for us, which is change in velocity. So if I talk about from t1 to t2, right? Say for example in this second graph. If I say this is the graph, AT graph, and I talk about from t1 to t2, calculate area under the curve, this trapezium, then it is going to give me change in velocity from t1 to t2. right? Delta V, which is equal to velocity at T2 minus velocity at T1. All right? Okay. And you would understand that this is a, yes, magnitude of the vector quantity that you are going to get. All right? Okay. Now that we've understood about area under the graph, right? We've talked about displacement time graph, we've talked about velocity time graph, and we've talked about acceleration time graph. We know what the slope gives and what area under the curve gives. Now let's come to the next thing that we have. Yes, area under the acceleration time graph. So again, just like we did in velocity time graph, here also if we take special circumstances, right? And again, very commonsensical. If I take special circumstances and I say this acceleration time graph is a horizontal straight line, that means it's a constant acceleration. So if it's a straight line but not horizontal, that means it's a increasing acceleration, right? And if it's, well, a general kind of a graph, then it's a general kind of graph, right? Now, if I talk about the area, I will say that in here, change in velocity is a times T2 minus T1, area of the rectangle. In case of this, it's area of the trapezium, delta V, change in velocity from T1 to T2, right? Half A2 plus V1 into T2 minus T1, right? And you don't need to remember all of these things. I'm just telling you so that once you try to understand, you look at area under the curve, if you find out familiar shapes, right, mathematical shapes, all you need to do is apply area of that mathematical shape, whether it's a square or a rectangle or a triangle or a trapezium, right? That's about it, right? That's the fun over here. Now that we've studied this much, let's solve questions, yeah? Okay, so here we go. Another question. As I've told you, learning concepts is one thing, applying concepts in question is another thing, right? So here we've got a velocity time graph of a linear motion, right? It's shown in the figure. For the particle, find the net distance covered and displacement at the end of 8 seconds. Come on, guys. Quickly solve this question. Two things are asked here. Here we have VT graph and we have to find out distance covered and displacement, right? At the end of 8 seconds. That means from 0 to 8 seconds. Tell me, what is the answer coming out? Yes, good question, Anjali. Anjali is asking, what if the graph is below x-axis? See, if the graph is below x-axis, over here, see, if I talk about here, this is giving me, y-axis is giving me value of velocity, right? That means, if it's below x-axis, value of velocity is negative. What does that mean? The particle is traveling in negative direction, right? So it's a linear motion, one dimension motion. If I say one direction is positive, the other direction is negative, whenever velocity time graph is above x-axis, it is traveling in positive direction. Whenever it is below x-axis, it is traveling in negative direction. Okay? All right. All right. So we should take only magnitude or with sign. Well, it's a vector quantity, right? Take sign. To calculate displacement, we need to take it with sign. And here we go. Area under the curve gives you displacement, right? So in here, area under the VT curve is going to give you displacement. What do we say? Total area is going to be equal to this whole area, right? Yes, this is positive area. Why? Because it is above x-axis. This is negative area. Why? It is below x-axis. So we will add these two with sign for displacement. Okay. All right, let's calculate these values. Here we go. We have the figure. If I say this is A1 and this is A2, then what are these? These are trapeziums, right? Yeah. So area of a trapezium, you know how to calculate. Half into sum of length of parallel sides into distance between the parallel sides, which is 12 unit comes out. What about A2? Another trapezium, again half into sum of length of parallel sides into distance between the parallel sides. Again comes out -6, right? Keep these areas with sign. If I want to calculate displacement, I will add these two areas with sign. So what do I get? Displacement comes out to be 12 minus 6, which is 6 units. On the other hand, if I want to calculate distance traveled, what do? See, in the first part of the motion, particle's velocity is positive, that means it is going in positive direction. When velocity became 0, it turned, right? It turned and it traveled in the negative direction. That means total distance, if I have to calculate, it will be forward distance plus the backward distance. Forward distance traveled plus backward distance traveled, right? So I have to take these two values, take their magnitudes and add. That's what we are going to do. Distance traveled by the particle will be mod A1 plus mod A2. Take the magnitudes of the areas, add them up, we get 18 meters total distance traveled. Make sense? Looking at the graph only, you can figure it out. In the first portion, particle is traveling in positive direction. When velocity became 0 momentarily, that is when the particle turned back, it reversed its direction, and in the second graph, in the second part, as you can see, velocity is below x-axis, it's traveling in the negative direction. So, do you understand this? Alright. Displacement comes out 6 meters and distance comes out 18 meters. Alright. Now that we've done this question, right? Alright, Janvi, how 2 plus 4, huh? Okay. As you can see in this particular trapezium, see, these are the two parallel sides, right? So this is 2 units, this is 4 units. A1 ke liye. For A2, we have these are the two parallel sides, 4 and 2, right? Sum of parallel sides multiplied by distance between the parallel sides. Here's the distance and here's the distance. That is how we calculate area of trapezium. Okay? Alright, I hope you understood this. And now that we've solved this question, let's go to the next question. Another graph question. Let's solve this. And yeah, this is a concept-based question, right? A conceptual graph questions. Please pay attention. A lot of conceptual graph questions do come in Neet. Okay? At least a lot of graph questions come in Neet. Alright? Okay. Here is a question. Among the 4 graphs given below, identify the correct one for which the average velocity over time interval 0 to t, any time interval 0 to t, can be 0. Okay, that's the question. Out of these 4 graphs, which graph can have average velocity from 0 to t 0? It can be 0. If you want to calculate average velocity, what do? We say average velocity is nothing but total displacement upon time taken, right? And when we talk about slope of secant, right? Slope of secant in an ST graph, that is going to give us the value of average velocity, right? Slope of a secant drawn for a given time interval in an ST graph is the average velocity. So now let's look at the graphs one by one, yeah? If I look at the first graph, I'll say that to get average velocity as 0, I need to have slope as 0. That means I need to have secant as a horizontal line. Does this make sense? I need to be able to draw a secant which is horizontal. Now here, can I have any 2 points where I can draw a secant as a horizontal line? No, right? Not possible in the first case. What about the second case? In the second case also, no matter where I take the points, right? If I take these 2 points, again, no dice. If I take these 2 points, again, no. I don't get a secant that is horizontal. Again, not possible. If I take the third graph, am I able to take? No. No secant for which the slope is 0. But if I take the fourth graph, I will say that here is a secant that can be drawn for which slope is 0, right? There we go. So I can say that yes, in the fourth graph, it is possible we can get average velocity equal to 0 for 0 to t time interval, right? It is possible. Do you understand this? So answer to this particular question is going to be equal to option number D. That is our answer. All right. I hope you understood this. Do remember this concept, right? And this again can be applicable for average acceleration and calculation in VT graph also, right? Here we looked at the concept. See, here we talked about slope of a secant drawn for a given time interval in an ST graph, and we talked about average velocity. Take the same analogy and go to VT graph. The slope of the secant will give me average acceleration, and the same question can be asked with a VT graph for acceleration as well, right? Okay, all right. With this question, we are going to end this session over here. All right, I hope you understood everything. Here we go. At the end of the session, we've got these mind maps. So whatever we learned in this particular session has been condensed properly, and this notes will be provided to you after this session. So do keep these with you, right? The important terms that we learned about: distance, displacement, position vector, displacement vector, average speed, average velocity, instantaneous speed, and instantaneous velocity. Next, we learned about 3 equations of motion, right? In uniformly accelerated motion. When we talk about motion under gravity, that is also another type of uniformly accelerated motion. Displacement in nth second, and then we talked about graphs, right? We started with displacement time graph, we went to velocity time graph, we went to acceleration time graph. What happens with slope? Slope of a tangent gives me instantaneous value, slope of a secant gives me average value, right? Velocity in case of ST graph and acceleration in case of VT graph. Now, when we talk about area under the curve also, in case of ST graph, we don't talk about area under the curve. In case of VT graph, area under the curve is displacement. In case of AT graph, area under the curve is velocity, or rather change in velocity, delta V vector. Okay? All right. Here we go. With this, I will end this session. Now, after the session is done, please guys go and practice questions, and do make sure you practice with time. Until next time, happy learning.